Lesson 2. Operational Mathematics for Business Efficiency. Welcome back, intrepid learners. Today, we're zeroing in on the operational side of business mathematics. Operations are the engine room of any business, and mathematics is the fuel that powers efficiency and optimization. Get ready to see how theory translates into operational excellence. Linear programming for resource allocation. In the quest for efficiency, linear programming stands as a beacon, guiding businesses in optimizing resource allocation amidst constraints. Linear programming is a mathematical approach used to optimize resource allocation in a business setting. It involves setting up a mathematical model and using algorithms to find the best possible solution that will maximize profits or minimize costs while taking into account various constraints and limitations. This method has wide-ranging applications in fields such as manufacturing, supply chain management, operations research, and transportation, among others. The goal of linear programming is to find the most optimal solution by maximizing or minimizing an objective function, which is a mathematical representation of the goal of the business. This objective function is subject to constraints, which are limitations on the amounts of resources available. Constraints can include factors such as budgetary restrictions, time limitations, and the availability of materials. One of the key strengths of linear programming is its ability to handle complex problems with many variables and constraints. It allows businesses to make data-driven decisions, taking into account various factors that may affect their operations. By using linear programming, businesses can optimize their resource utilization and maximize their profits, leading to improved efficiency and competitiveness. Another important aspect of linear programming is its ability to provide multiple solutions depending on the specific objectives and constraints considered. This allows businesses to explore different scenarios and evaluate the potential outcomes before making a decision. By considering various options, businesses can make more informed and smarter decisions, leading to better overall performance. Moreover, linear programming can be used in combination with other mathematical or statistical techniques to provide a more comprehensive analysis of business problems. For example, it can be combined with sensitivity analysis to determine the impact of changes in parameters on the optimal solution. This not only helps businesses make better decisions but also allows for ongoing monitoring and fine-tuning of operations. Case study: manufacturing optimization. Consider a furniture manufacturer juggling production lines for chairs and tables, constrained by labor hours and material costs. One possible production process for a company would involve building chairs and tables separately, with dedicated production lines for each item. This process would involve setting up separate production lines for chairs and tables, each with a specialized team and equipment, and managing the flow of materials and labor between the two lines. Alternatively, the company could use a parallel production process. This would involve setting up a single production line that is capable of producing both chairs and tables. This production line would be staffed with a flexible team that is trained to work on both types of products. Materials and labor would be shared between the production of chairs and tables, allowing for improved efficiency and cost savings. Another option for the furniture manufacturer would be a mixed production process. This process would involve setting up one production line that is capable of producing both chairs and tables, but the production would be done in a sequential manner. This means that the production of one type of product would be completed before moving on to the production of the next product. This process would allow for a more specialized approach to production, as the team working on each product would only have to focus on one type of furniture at a time. The final option for the furniture manufacturer would be a just-in-time (JIT) production process. This process would involve producing furniture only when it is needed, minimizing inventory and waste. The production line would be set up to quickly switch between chairs and tables, based on demand. This process would require careful planning and coordination to ensure that materials and labor are available when needed, but it can lead to significant cost savings and increased efficiency. Ultimately, the best production process for a furniture manufacturer will depend on their specific goals, resources, and market demands. Each process has its own advantages and trade-offs, and it's important for the manufacturer to carefully consider their options before making a decision. Regardless of the chosen process, effective management and coordination are key to successfully juggling production lines and maximizing productivity. Through linear programming, we'll explore how they maximize profit while navigating these constraints. Linear programming is a mathematical optimization technique utilized by businesses and organizations to make efficient decisions while considering various constraints. These constraints can include limited resources, time, budget, and legal regulations. By using linear programming, businesses can determine the best course of action that will result in the maximum profit or desired outcome while adhering to these constraints. In the context of the fashion industry, companies may face multiple constraints when producing and selling their products. These can include a limited budget for purchasing materials, a strict production timeline, and regulations regarding fair labor practices. Additionally, there may be limitations on the availability of certain materials or the demand for particular styles. To effectively manage these constraints and maximize profit, fashion companies can use linear programming. This involves formulating mathematical models to represent the company's objectives, constraints, and decision variables. The objective may be to maximize profit, minimize costs, or achieve a certain level of customer satisfaction. Decision variables in the fashion industry may include the number of pieces of each style to produce, the amount of fabric to order, and the pricing strategy for each product. These variables are interrelated, and the goal of linear programming is to determine the optimal values for each variable that will result in the most profitable outcome. For instance, a fashion company may use linear programming to decide how many units of a particular dress to produce given the available budget for materials, the production timeline, and the expected demand for the dress. By considering these constraints and utilizing linear programming, the company can determine the quantity of dresses to produce that will result in the highest profit margin. In addition to maximizing profit, linear programming can also be used to optimize other key performance indicators, such as minimizing production time or reducing waste. This can help fashion companies become more efficient and competitive in the market. Exercise. Solve a linear programming problem. Using a simple linear programming model, calculate the optimal production mix of chairs and tables to maximize profits, given specific constraints on labor and materials. To calculate the optimal production mix of chairs and tables, we will use the following linear programming model. Objective function. Maximize profit equals 8x plus 5y, where x equals number of chairs produced, y equals number of tables produced. Constraints. 1x plus 2y is less than or equal to 200, constraint for labor hours. 3x plus 2y is less than or equal to 300, constraint for materials. X is greater than or equal to 0, non-negativity constraint. Y is greater than or equal to 0, non-negativity constraint. Solving the model using a linear programming calculator, we get the optimal production mix. Number of chairs, x, equals 100. Number of tables, y, equals 50. This means that to maximize profits, the company should produce 100 chairs and 50 tables. This will result in a profit of $800, 8 chairs x $8 profit per chair, plus $250, 5 tables x $5 profit per table, equals $1,050. It is important to note that this is just an example and the actual optimal production mix may vary depending on the specific constraints and profit margins of the company. Inventory management models. Next, we step into the world of inventory management, where mathematics ensures businesses have the right stock at the right time without tying up unnecessary capital. One of the key principles of inventory management is the optimization of inventory levels. This involves using various mathematical models and algorithms to determine the optimal level of inventory for a business to keep on hand. This is based on factors such as demand forecasting, lead times, and production constraints. Optimizing inventory levels helps businesses avoid stockouts when a product is out of stock, and excess inventory when a product is overstocked, both of which can be costly for a business. By using mathematical models, businesses can accurately calculate the optimal levels of inventory to maintain, taking into account various factors that can affect inventory levels. One commonly used mathematical model in inventory management is the economic order quantity (EOQ) model.